we're going to look at 2007B, number 6, and we're going to start with A. So you notice that all of these elements, they say, are from period 3 on the periodic table, so they're all from this row right here, which means we might be able to identify them. But let's look at A. It says, which element is the most metallic in character? Metallic is one of the least useful trends out there, and I'm not sure they're going to ask it anymore. But you remember that the dividing line between being metallic and not metallic is right there, and all these are metallic. So the more this way you go, you can get away from the non-metals. And so the more left and the more down we go, the more metallic something will be, just because it's farther away from the periodic table from the non-metals. So you notice that francium here, it's going to have very, very, very low ionization energy. Remember, fluorine has very high ionization energy. This one's going to be easy to remove electrons. So we're going to say that probably element 2 is the most metallic, because you'll notice that it has the lowest ionization energies. It also, you notice, loses 1 electron, and then the ionization energy jumps up a lot. So I think for A, the answer is going to be element 2. So I'm going to say element 2 because metallic elements have low ionization energies. I'm not sure if we need to explain it further than that. We certainly could, but I think that that's probably good enough. While we're here, let's do B. So B, they want to know what is element 3, and explain your reasoning. So we got to determine how many electrons element 3 likes to lose. Well, it's almost twofold to go from there to there, and it looks like there's a significant jump from the second to the third, much more than twofold. So I think this is going to be an element that loses 2 electrons and then doesn't like to lose a third. And that's probably going to be magnesium. It loses 1, loses 2 to get back to be isoelectronic neon, and then doesn't want to lose another one. Alright, so element 2 is magnesium. The most common ion of magnesium is Mg+2, and the ionization energy data suggests element 2 has a low ionization energy for loss of the first 2 electrons. I think that should be good. Part C should be pretty easy, since we determined in Part B that this was magnesium. It should be pretty easy to write the electron configuration, and that should be it. You'll notice that in this one and in D, we don't have to explain our reasoning, because they will say if we need to spend time doing that. So in D, they want to know what is the expected oxidation state of element 2. Notice element 2, it's almost 10 times the energy losing electron 2, whereas it's not even close to 10 times to lose the next one. So I think this is, element 2 is one that likes to lose 1 electron, but not 2. So it's probably going to be sodium here. It likes to lose 1 to become like neon, but not 2. So the most common oxidation state is going to be +1. Oxidation state meaning just charge. Alright, E is pretty easy too. What is the chemical symbol for element 2? Well, we already decided it was sodium, so that's pretty straightforward. And then lastly, F, a neutral atom of which of the 4 elements has the smallest radius. Remember, smallest radius is going to be down here, and over here it's going to be, actually I'm in the wrong row. It's going to be over here, and the biggest one's going to be over there. So we're looking for something pretty down far to the right. And lastly, part F, which of the elements will have the smallest radius? You remember the ones that are really, really small will have their electrons closer to the nucleus, and they'll be attracted more, which means they will have much higher ionization energy, because it's going to take a lot of energy to remove them. So we're essentially looking for the one with the highest ionization energy. And I think that's probably going to be element 1. Yeah, it looks like it's going to be element 1. So, surprisingly, they didn't say explain the answer here. But I definitely think it's going to be element 1. And if we were going to write out an explanation, it would be because the smaller atom has the higher ionization energy, and that has the highest first ionization energy.